What's going on, you guys? Mr. Allen here with an introduction to the wonderful land of circles in geometry here, man. Circles have a ton of stuff going on here, but we got to start somewhere, right? We're going to go with our basics of our circle. So this right now would be called circle A, right? My center is A, so we label it as circle with a little dot, A. Beautiful. Fantastic. All right, now, what would my radius be? So my radius, which one's my radius here? My radius goes from the edge of the circle to the center of the circle, so segment AB would be my radius for this one. Beautiful. How about diameter, right? So diameter, there we go. So my diameter goes all the way across the circle, and it also contains the center. So CD is going to be my diameter here, or DC, because apparently I wanted to write D first. Maybe it's because I was saying diameter. I don't know. Lovely. What is this green line that I have over here? I did make it green, so it would really pop. You know what I'm saying? All right, well, EF, that is called a chord. Okay, so a chord would be EF here. So there are an infinite number of all of these things here. There's an infinite number of radii, an infinite number of diameters, an infinite number of chords, right? A chord is just any line from edge to edge of the circle, anywhere in the circle. Then our diameter is like a special type of chord because it goes through the center, right? So a diameter is still a chord, but a chord is not necessarily a diameter. That's a good test question. All right. So I get to draw a chord, shoo, boom, right here, boom, right here, boom, right here. That's also a chord, but it is my diameter. Okay. We cool with those things? Cool. Now let's get some of our basic formulas, right? We're talking area and circumference. So circumference here, circumference, let's go with, you know what? I'm going to throw it, now I'll do it here. Okay. So circumference, boom. Right, circumference has two formulas, right? We have circumference equaling 2 pi r, or you could have circumference equaling pi times, what's 2 times r? That's my diameter. Boom, pi times diameter. Excellent. How about area, right? Area is another biggie for us. Area. I always want to find the area of my circle because that would be like my pizza. You know what I'm saying? All right. There are some dope ones. Maybe I'll link it in here. Area of a pizza. It comes in handy, man. I was eating one of those frozen Lou Malnati's pizzas, and I was like, how much do I eat, right? Do I eat the whole thing? Half the thing? What do I do? Well, I found the area of like 2 or 3 slices of the normal big pizza that I get, and it was the same, about the same, as one of those small ones. So I ate the whole entire pizza, right? But I mathed it up prior to that, right? I was hungry for math and pizza. So area is going to equal pi times my radius squared. Cool. Those are 2 basic formulas. We'll get into other things like arc length and all that stuff here in the future, but those are the big ones, okay? So now, let's go ahead and find my area and circumference of this circle. Let's say that AB here is going to be, how about 8 feet, okay? Clearly, 8 feet. Maybe this is just scaled down, okay? So circumference, my circumference is going to equal 2 times pi times my radius of 8. So my circumference is going to be 16 pi. Feet. There we go. Now, we could also get this into an approximate form, right? We could approximate it by taking out that TI-84 plus graphing calculator or whatever one you got. I'm always rocking this bad boy. So we got 16 times pi. So if you hit second caret, that's where the pi button is. We ain't using 3.14. If you use 3.14, I'm going to be upset, right? Yo, bro, you only round once, okay? So we want to make sure we use pi that's built into our calculator. 16 times pi gives me approximately, I'm going to use squiggly equals now, approximately 50.265, so 0.27. That 5 rounds that 6 up, and that would be, again, feet. Love it. Fantastic. How about my area? Okay, area is another one that is wonderful, yes. So area is pi r squared, so my area here will be pi times my radius, which is 8 squared. Excellent. What's 8 squared? That's going to be 64 pi, and this is going to be feet squared because we're talking about area. That would be my exact answer for the area. So this will say exact, and you think like, oh, decimals? No. Decimals are approximate because I'm putting it in here, then I'm rounding it. Once it's rounded, it's not exact anymore. But I can type in 64 times pi, second caret for pi again, and we'll get 201.06. So approximately 201.0606 feet squared. Excellente. So there is my approximate area because I rounded it. It's decimals. But I think decimals are really nice when we're talking about real life type things, right? If we're finding the area of a circle and want to know actually what the area is with whatever you're doing. Maybe you're doing some kind of a garden here and you got to figure out the area of like planting flowers and stuff like that. On the packaging, they'll say like how much it will cover, right? Or you're painting or whatever area is important. Decimals are important for that. In our math classes, we often leave things in terms of pi because it's a little easier to operate with and it keeps things a little more neat. You don't have to deal with decimals. You're not have to keep all these things in your calculator. So advantages to both. That's about it for our introduction on circles. I hope you continue this journey with me in this wonderful circles playlist because the problems are pretty awesome. And we're going to do some big stuff outside. It's going to be dope.